Composition, materials, main purpose, again, what are they made from, why are they made from these materials, and so on. And we start with some trivia about how to number your coating positions. Now, it's all plain and simple. Every glass has two sides. If we start counting the glass sides from outwards to inwards and number them, then we can clearly indicate the position of the coating in which the coating should be. So, for example, here the sides are 1, 2, 3, 4, and coating here is in position 3. Basically, no questions, no problems here. The only confusion can come out if you are having a laminated glass inside your IG units, because some people are counting this glass as single glass and numbering it in the following way: the position 1 and position 2. Usually it works out just as well, but sometimes in rare cases that you got a coating laminated to the film, meaning the coating in position inside of the laminated glass, then you can have a confusion. In this case, it is far safer to count every position of every glass in the IG unit and just number them in the same way. Thereby, you will never confusion position 2 with position 4, and you will never put the coating in the wrong way. So basically, that's the easiest part. Moving on. Now we have come to the other than glass materials, and we start with the primary sealant. Primary sealant is made up of butyl here. Butyl is a black elastic material, and it has two main purposes in IG unit. The first one is butyl is what holds the glass together during the production, before you apply a secondary sealant onto IG unit and before it solidifies. And the second, in its main purpose, it makes your unit, IG unit, sealed. So it helps you, it saves you against gas diffusion inside the IG unit and water vapors diffusion. So basically, how airtight your IG unit is highly dependent on primary sealant. So why primary sealant is so important? Primary sealant has to have two basic functions. It has to be always elastic and not solidify as a secondary sealant. Here, secondary sealant. Why so? Why is that so important? Because during the lifetime of IG unit always breathes, so-called. The glass are constantly moving, albeit very slowly, because IG unit is made the same this way. You see, the amount of gas inside the gap is a constant one. As you made it on the production, let's say at 20-25 degrees centigrade, so the amount of gas is the same. The volume of the gas, however, can change if the IG units get heated up, then gas expands and glass bends. Or alternatively, the volume of gas can shrink if it gets into the cold conditions. So you see, depending on the temperature, glass is moving, everything is moving. So primary sealant, butyl, have to be elastic all the time. And to serve its second purpose, it should have all the time very good adhesion, meaning it needs to always be stuck either to spacer and to the glass. So create a barrier through which gas and water vapors, most importantly, cannot go inside. So that's why primary sealant is so important. Again, have to withstand every IG unit movement, glass movement during the lifetime, and to be always airtight. And that is why that the butyl should be always positioned evenly on the borders of your spacer. You should not have any breaks, because this is a critical fault. For example, here you can see a perfect application of your butyl, even everywhere, even on the corner, because corners and spacer connections is the weakest point in all of the IG units. While here you have a break. Here, again, one of two most important places in your spacer. This is a connecting part. It should be sealed very, very good. But in this case, as it is seen of the photo, it is having a break. And by all standards, a butyl break is considered a fault of IG unit, because through the break, water vapors can get in and the water can condensate inside the IG unit, obviously making it faulty. So these are the two main problems of the butyl. Another problem which you can encounter is that during the IG unit lifetime, butyl can expand inside of the IG unit. Now, this can be caused by several factors. First of all, if you put too much of the butyl on the both sides of your spacer, then it can get heated up by the sun, for example, and begin to expand slowly. Now, while not a really critical fault, this is a visible fault, visible by everyone and the customer also. And that is what makes, and the visible part creates a concern about what is this, how is that possible, is it a defect, replace me an IG units or something like this. Now again, the standards are regulating the height of this butyl by making it no more than 2 millimeters. Okay. Can it expand more? Yes, in a very special cases. For example, if you're having a bent IG units, cylindrical bending, there is IG unit is very stiff, meaning the glass have a cylindrical shape and cannot move. They cannot expand if the pressure rises. That cannot really shrink if the pressure decreases on the cold conditions, under the cold conditions. And that creates a lot of pressure in the butyl section. That is the one factor. The second factor in the bent IG units is that butyl in bent IG units always applied manually, because all of the bent IG units are made only manually, without any IG unit lines or something like that. And therefore, bent glass have a little bit of distortions for which you want to compensate, and you apply even more butyl. So there, butyl can expand even more than 2 millimeters. And that should be mentioned to the customer in the first place, even before the order is placed. So even before you even start thinking about it. That's one thing. And second thing, you can use black spacer, because on the black spacer, the butyl expansion is much less visible. So that's how to deal with the probable butyl expansion. But the most important thing for an IG unit producer is to control how much of this primary sealant you're putting on your spacer, and you need to control it regularly. Basically, on all good factories, this is done every day at the start of this production. So yeah. Now I think we're done with the primary sealant. Again, any questions? Feel free to post them. Now we're moving to the spacer. Usually the spacer material is aluminum. The cheapest, the safest, and the most widely used solution for the spacer. Aluminum has all of the advantages. It is very technological, meaning it can bend on the corners easily. Cheap again, reliable, and aluminum has a very good adhesion to the primary and secondary sealant. Everything is good apart from one thing. Aluminum is a metal, and the heat conductance coefficient is very high, meaning the aluminum spacer creates a so-called thermal bridge, meaning the heat is freely moving through the metal, out or in, depending where it's hot and where it's cold. So aluminum spacer is compromising the U value of your whole window or facade system, basically of the edge area of an IG unit. Now, for that purpose, composite spacers are widely used. Sometimes even purely plastic spacers are used, so made purely out of plastic. But personally, I wouldn't advise using them because plastic as a material has another faulty thing. It has very poor adhesion to the butyl, meaning the air tightness of your IG unit is poorer than if you have aluminum or composite one. Now, composite spacers are made out of plastic and metal. Plastic to reduce your heat transfer, and metal to make butyl stick to it, so your unit with IG unit will be airtight. Okay, every spacer can be made in different colors, namely black. Again, very useful if you have a butyl expansion problems. And butyl expansion problems is a great thing in a hot climates when IG unit can get heated up rather quickly under the powerful sun. So yeah, black spacer is a good thing, in my opinion. So the spacer can be made in two ways. It can be bent on the corners and connected on one joint or several joints. Or alternatively, the spacers can be cut into several bars and then connected at the corners. Now, every connection is a potential for your IG unit being less airtight than it should be. So every connection is a potential that water vapors can get in. Basically, the less connections you have, the better. So in terms of airtightness, bent spacer is preferable. Now, some types of spacer, for example, structural steel spacer made by Schuko, cannot be bent on corners. It can be done only in this way. Okay. Then the responsibility of IG unit producer is to seal all of the corners carefully with butyl to be sure that it is going to be airtight. Because again, these joints are very critical. If done properly, your IG unit can stand 10, 20 years or even more without have any problems with getting water vapors inside for some reason or another. Now, I think that was the most important part about the spacer. Now we're moving to the molecular sieve. Yeah, these granules. That's how they look like in real life. And also on this picture, you can see how not to do a corner bending. I've specially put this photo on, so you see, this one had a lot of like distortions, which is obviously a bad thing. Now, this part is done much better. So also look at the edges, on the corners of your IG units. Maybe this one was done with the proper instrument. Now, when we'll be talking about this molecular sieve. These are round granules positioned inside your spacer, and they serve a very specific purpose. They should absorb all the water vapors from inside of an IG unit, making gas inside IG unit completely dry. Now let's talk how does this granulus do it. If we imagine that we are a molecule of any gas, and we will be looking at this big round piece of molecular sieve, then we will be seeing something like a giant moon. All of its surface covered with holes, and inside this huge moon, there is a huge labyrinth. So basically all of the surface of this sieve is covered with tiny holes through which water molecules can get through. A very important part is that these holes, and it is clearly stated in the molecular sieve marking, these holes should be no more than 3 angstrom. Angstrom is a very, very small. So 1 angstrom is 10 with the power of -8 meter, of course. Why? Why this number? It serves a very distinctive purpose. And we need to delve a little bit into physics to explain. You see, every molecule of the gas has a parameter of gas dynamic diameter. This can roughly be explained without going deep into the physics as a diameter of this molecule in the gas. So for water vapors, for water, it is 3 angstrom. For other gases like argon, nitrogen, oxygen, their diameter of their molecules is about 4 angstrom, so more than 3. So what happens with the molecule? If the water molecule comes to this big round piece of molecular sieve, it sees the holes, it can get through the hole inside of the molecular sieve, and there it is basically lost in the never-ending labyrinth. Other molecules cannot push itself through the hole inside, so they happily living outside of this. And that gives this molecular sieve an ability to selectively absorb water vapors from inside the IG unit through these small holes in the spacer. They are specifically made to ensure that your gas can circulate in and out of the spacer. And thereby, it absorbs only water and nothing else. All the gases are left as they are. I think a perfect condition, perfect dryer for a gas inside. Okay, now what faults can molecular sieve have? Yeah, as always, there are some. At first, you need to use proper molecular sieve with 3 angstrom holes. Now, there does exist a very cheap molecular sieve with the hole of 4 angstrom. It cannot be used for IG units for obvious reason, because it will eat away any gas inside of this cavity and leave the water. So it will not leave the water. It will not selectively eat away the water vapors. So use proper molecular sieve. Molecular sieve has to be dry when put into spacer. Again, controlled on the production side. And molecular sieve should have a granulus of about the same size. Now, if it does have some small granulus, it can pour down through these holes inside of an IG units, which is bad. Molecular sieve can be plagued with dust. Microscopic particles of this molecular sieve then, during transportation, can get through the holes and be left on the inner surface of your IG unit, creating like a dusty, whitish look. obviously that is a defect of molecular sieve. So the only advice I can have is use a good one. And in any case, watch for molecular sieve and it will perform perfectly until your sealing of your IG unit is breached. So that's about it for molecular sieve. And now we are moving to one of the most important parts, the secondary sealant. Sorry for the censored mark. I have to put them after somebody noticed that said that we are promoting certain types of, let's say, polysulfide or silicone. So yeah, I've put this one. So what does a secondary sealant do? A most important function of a secondary sealant is to hold the glass together. That is the material that holds the IG units as a whole. I have some question. What is the best safe molecular sieve for 12mm spacer? Interesting question. It usually depends on the type of filling you're used. Is either manual or automatic. What should be the delta temperature? So again, it is always stated in the sieve. So for ease, we can either be left for after the webinar when we discuss this specific, or we can get in contact by email or phone to discuss, because that would be a discussion for 10+ minutes, I guess. Okay, thank you for understanding. As always, I will be showing my contact number and the email in the end of the presentation. So just let me know and we'll get in contact. Okay, so polysulfide. Oh yeah, secondary sealant, I mean. Sorry, was held off the track. So yeah, it holds the glass together. Now, how firmly it holds and how much weight or how much force it can withstand is depending on the secondary sealant depth. Basically, the more secondary sealant you apply, the more it can hold. Now I will explain. For example, you have an IG unit like this. Sorry, I will use my phone as an example. So you made it. You see, you apply the secondary seal. Secondary seal solidified. So basically, IG unit is ready. So what do you usually do upon installation? Here is an IG unit. You have a suction caps. You take it on the one glass, and then you start to move it with the suction caps to install. This side, this glass, is held in the place only by the tiny band of the secondary sealant. Now imagine if you have an IG unit, let's say of size 2 meter by 4.5 meter. And outside is a 10mm glass, which is very heavy in this case. So in order for this 10mm glass to hold on its place, not fall down, not slip, you have to apply more than usual. For a normal IG unit, the standard secondary sealant depth for polysulfide, we'll be talking about the polysulfide first, is about 4mm. If you're dealing with the heavy glass on a big IG units, the depth can be twice as much. In the case I mentioned, like 2 meter by 4.5 meter, something like this. Now that's about the holding capacity. We'll be talking more about secondary sealant depth further down the presentation. And basically, we'll be talking now about polysulfide. Polysulfide is used for IG units for windows, for transom mullion system, just for normal one, but not for the structural glazing. Because one of the disadvantages of the polysulfide is that it is basically afraid of being put under the ultraviolet radiation. So on the project, it should be covered with aluminum profile from an outside, something like this. So the solar rays cannot pierce through. But it should be also protected while the IG units are not installed. Now imagine the situation. You have brought an IG unit to the construction site of the building. And they're on the pyramids, they're put outside of the building. And that can last for several days, if not weeks. Now, during that time, polysulfide has to be protected from direct sunlight. If in case it is not, in southern countries, the sun is very hot. It contains a lot of ultraviolet. Russia is much colder, and ultraviolet here is far less. So then, what happens to the butyl? It changes. It becomes rigid, very solid. It loses its elasticity. Now, if you're pushing your finger into the good secondary sealant, you should feel it like a resin. You can push, it pushes you back, so elastic. Now, if exposed to ultraviolet, polysulfide loses its elasticity. It's become like a wood or stone. A little white haze can appear on the surface, and you cannot push it with your finger. Now, what is so bad in it? Now, as we talked in the beginning of the presentation, IG unit always moves, always breathes. And if your secondary sealant solidifies, then it cannot adapt to the changing geometry. And there, breaks will appear. So basically, your polysulfide will break away from the glass, and it will lose its carrying capacity, secondary sealant, and it opens up a gap for water to come through. Because two of these should always work together. Primary sealant is giving you water vapors protection, and the secondary sealant giving you a water protection. I mean, direct water. And if secondary sealant fails, IG unit will fail soon enough. So protect your edges, even on the construction site. Do not expose them to the sunlight. A certain care has to be taken not to cover everything. The IG unit should have some ventilation. So this pack of IG units shall not overheat under direct sunlight, because in this case, if you have some non-temperable glass, it can break. So here, a little bit of advice how to handle it. Now, believe me, this is very critical one. Now then we are coming to the sealant, which is different. This is a silicone. And it has also some advantages and disadvantages. The primary advantage being that it does not care for the ultraviolet. Absolutely. Ultraviolet cannot harm a silicone. But the disadvantage being that silicone is more expensive than a polysulfide. That's the first thing. And the second thing, the minimum secondary sealant depth of the silicone is 6 millimeter instead of 4. Now, I know that some saying that for polysulfide minimum depth is 3 millimeter. But let's be clear. Every production can have a deviation of any parameter of about 1 millimeter. And 3 can easily become 2, which will not hold the glass, hold the glass in place. So I'd say minimum 4. So with the tolerance of 1 millimeter, you will get to the usual 3. Now silicone is 6, and this is stated by every silicone producer. Silicone is better overall, apart from being much more expensive. because it doesn't give crap about the conditions which you are handling it. And because it is not afraid of ultraviolet rays, it can be used in a structural glazing. Now that where the silicone depth is coming into play. Now on that picture, I will be showing you one of the defects which is critical on every secondary sealant. So please be careful to look for the gaps and holes inside the sealing. It should not have. Because here, basically in this place, your IG unit can fail during its lifetime. Because at first, the holding capacity of the secondary sealant here is severely compromised. And it's even worse in the colder climates because these gaps can be filled with water. And when exposed to the negative temperatures, the water can freeze and then tear it apart from inside. This is a critical one. And if we started to talk about the secondary sealant depth, let's move on to the structural glazing. As you can see on this picture, the outer glass here is basically held only with silicone, only with the secondary sealant. Remember what I told you about the suction caps and outer glass only sticking on the secondary sealant during transportation, installation, and so on. Now here, silicone holds outer glass for its lifetime, meaning all the time. And also it is exposed to all the kinds of loads, wind pressure, internal pressure. Imagine if the IG unit gets heated up and starts to bubble up. Outer glass is held only by the perimeter, only on perimeter, so it tries to basically tear it away. It should withstand this one. And all other type of loads, which can be found on the IG units, basically. So, and therefore, in the structural glazing, the depth of the secondary sealant should be calculated by the silicone producer. Excuse me. Now you need for the proper calculation, sorry, I'm stressing this a lot because this is very important. In order to calculate the depth of the secondary sealant, you need to provide silicone producer with the following information. Size of your IG unit composition, which glass you're using, what thickness, and so on and so on. What is the spacer distance? The place where the IG units be used, I mean geographical place, like Moscow. Then you have to provide him with the height, the building height on which it will be used, in order to estimate the wind loads. Of course, the installation angle, whether it be vertical or at some inclination, back and forth. And you need to provide him with the details about how your IG unit will be held in your structural glazing system. Meaning, will it have any supports from the bottom part? And will it have any structural inserts? Now, as you see, the structural insert is basically the hole through which aluminum system holds your IG unit in place. It can be found in the variety of designs. Basically, a lot of aluminum profile companies have their own designs of the structural insert. So you need to provide full information about which structural insert do you use, how they will be positioned, because the total secondary sealant depth is highly depending on this. So imagine here in this place, in the place of a structural insert, In terms of holding the glass, the sealant depth is like this. So far, far less than an ordinary one. Is this a triple glass? Yes, this is. Sorry, I've used a different type of pictures just to demonstrate. For the double glass, the system is the same. You just have a different length of the screw and the facade system. The principle of holding the structural glazing is absolutely the same. This is double glass. So the structural insert should be somewhere here, but down the line. Another option, and you can see that here, IG-unit is held on the outer spacer, while in this system, it is held on the inner spacer. So you see, again, the difference. Now here is also a difference because this insert is not separately inserted into the silicone, but rather connected to a spacer. So here you will have this sealant to be holding all of your glass. Yeah, and there one camera, meaning two glass, is hanging on this spacer. So yeah, different design, different spacer, different depth. Again, I'm stressing you, this is very important, that the secondary sealant depths in case of structural glazing should be properly calculated all the time. And it should be done by professionals, those who know which loads to take into the account. Because if your structural glazing fails in this regard, then you may have like a list of glass to fall out from the top of your building. And believe me, this is not a good case. Especially when you are walking down below. So, glazing system may have no structural inserts whatsoever. And the IG unit can be held directly on the inner glass through these resins. And there is a cavity in the secondary sealant, which also made during the IG unit production. Okay, also an option, but it poses a special requirements to the inner glass, because inner glass need to be held on its place even when broken, but it has some holding capacity. So laminated glass with SGP or just laminated glass, I mean tempering laminated glass or heat strengthened glass are the options. While normal glass or plain tempered glass is not an option in my opinion, because if tempered glass breaks, it will lose the holding capacity. So, and under any load, it can jump out. Okay, if done properly, also an option. And the last thing I wanted to talk about for today, yeah, any questions? Which type is cheaper? Oh, it's highly dependent on which IG units you are making. In my opinion, this is solely my opinion based on experience. I would much prefer this type of the structural inserts. Now, a lot of companies have their own structural inserts, example, like Schuko. By the way, Schuko can be done in this way and also in this way. They use both solutions. Now, I'm not talking about Schuko now. I'm talking about the solution of position of structural inserts. In my opinion, this one is better because it gives you more flexibility. For example, here you can't really change the spacer width. Here you can. You can play with the depth of the sealant. So for this system, holding capacity of this solution is limited. Here you can adapt with a different depth of the secondary sealant and different positioning of your inserts. You can adapt to any IG unit weight, any IG unit configuration. In my opinion, this system is best because it allows you for more variety. Now, I'm not a commercial guy in any way, sorry. I cannot provide you with any numbers or costs. That is my fault in this case, in this regard. I can only provide you with the technical information. So in my opinion, this offers you a more variety, therefore it's best if done properly. This system is also not bad, but again, it has some restriction on inner glazing, and this system requires you to requires your facade guys to be kind of professional, so they didn't break or overscrew something. Sorry, I hope I answered the question, but in the way I could. Feel free to ask anything else if you like. And again, I'm not promoting anything. You can suspect me of promoting when we'll be talking about tempering, because there I have a definite preference, but again, it is my preference based on the 16 years of working on the tempering furnaces, the different ones, but that have to wait. And last but not least topic for today. Now, we'll be talking a lot about this when we'll be having a webinar about IG unit design, how to design an IG unit, and that will be a huge webinar done in 3 parts because it's way too big to be talked all at once in detail. Yeah, basically you can have a step glazing. A step glazing is a little bit of different beast. Now, the structural depths and structural inserts can also be for sure used here as a solution. And the step glazing mostly can pose you some kind of difficulties, or mainly the producer of IG unit, if you have some soft coating at an outside and a huge step. And the problems can arise during tempering process, but again, we'll be talking about it a little bit later. What I wanted to talk to you now is that in the step glazing case, you have to use silicone again, because it's obviously a structural one. And the step itself can also be covered with silicone. You just take the instrument and apply a thin, like 1 and 1.5 meter silicone layer on it. Basically looks very good from an outside. Alternatively, you can paint it with the ceramic paint. Best not to use bright colors like white or something else, because then you will have the distinct difference between this zone and this zone, because primary and secondary sealant are usually black. Now what I forgot to mention is that primary and secondary sealant can be gray in color upon demand, upon request, but this solution is rarely used because it implies additional costs. And also grayish color can differentiate on the facade. So, but okay, who am I to discuss the design preferences here? Okay, the usual one is black, of course. Another feature, if you remove coating and the step glazing part, then you may note slight stripes of a different tone. And these stripes are created when you remove coating on your cutting table, because your cutting wheel is moving in the opposite directions, thereby creating a little bit of visible distortions. Now, these distortions are not seen from afar, only very, very up close. But if the customer, for example, making himself a glass door, then that can become a problem.